Hello, my name is John Corliss, and today I'd like to go through the use of a tool that I've developed to supplement teaching a novice Git lesson, especially as part of the software carpentry core lesson on Git. This is going to involve working in a terminal, so I'm going to share my screen and walk you through it. Okay, I hope everyone sees the screen now. And let me just change windows here. So the tool is based on splitting a screen to present different information to learners. So what I'm going to walk through here is a brief introduction to the technique. What exactly is it? What do I mean? How does it fit with the current software carpentry Git lesson for novices? And then also, how might it be used for an advanced lesson? And then most of the recording here will be a live demo of this technique, and then a walkthrough of the script. So previously, we've talked about splitting the screen in teaching the shell lesson, and I have a reference to a blog post by Rainier. And there, I believe the motivation was to record the history of the shell lesson and then also have more commands visible to students during the lesson. And here I'm basically going to do the same thing, but the motivations are different. Really what I'm hoping to achieve is one half of the screen having a much more visual representation of sort of the basic Git structure of working directory, index, and repository. Those are fundamental in the conceptual understanding of Git. So my hope is that having this more visual feedback for students would help with understanding. Of course, we have to be aware of more information and the potential for more cognitive load. And I have to say, I have not field tested this, but I'm optimistic that it might be helpful. So what exactly is it? It's an IPython script. And what it does is it reads the current Git repo for a single file, and I've bolded that because that's important. And for that file, it will display the contents of the working directory in one section of the screen, the contents of the index, and then the repo commit history. And then with that on one side of the screen, that display, that representation, then on the other side, we can use that for the standard Git command line. And optionally, I've written a bash script that will automate the launching of the screen splitting tool I use, Tmux, and so on, but I won't be showing that here. So if we look at the current software carpentry novice Git lesson, these 12 topics are covered. And in terms of where might this tool help, I think it helps with the bulk of the initial work in understanding, creating repositories, adding, modify, add, commit, and then looking at diffs and merging and so forth. And so that's a pretty clear fit, I think. And then possibly, although I haven't really explored it, remotes at GitHub, or maybe even looking at conflicts. Again, the goal being trying to visualize things that are maybe a little harder to understand. And I also should say that I think this is useful in more advanced Git topics, and I will demonstrate that in the live demo, specifically moving on to branches, merging, and then also I'll show an example of rebasing. Okay, so now I'm going to move on to the live demo. Okay, so I have a terminal window open here, and I'm in the a directory called planets. And if I look and see what are the contents of that directory, it's empty. So I'm going to initialize a Git repository here. And now I'm going to run my script, which I have up one directory, and it's called git demo. And this syntax may look a little unusual, but when we do the script walkthrough, I'll explain why it takes this form. But I'm basically going to monitor a file that I will call mars.txt. It doesn't exist yet, but now I'm going to run this script. And what you see is that it's broken up the screen into 3 sections: working directory at the top with a blank space below it, then index or staging area with a blank space for that, and then finally repository on the bottom. And now let me split my screen here. So on the right-hand side, I'm going to issue sort of the standard commands that would be part of the Git novice lesson. And on the left-hand side, what you're going to see is in real time what the changes are doing to the various components of the repository of the Git structure. So as usual, let's write some information to a file, mars.txt. And since I specified before that that's the file I'm monitoring on the left, and that's what I need to use on the right. So I'm going to add a line to mars.txt. First line. And what you should see, of course, on the left-hand side now, the working directory section now is not blank, but it shows the contents of the file mars.txt. So if on the right-hand side, I cat that file, then of course it has the line that I just added, first line, and that's reflected in the left-hand side. Now if I add the file to the index with the standard git add mars.txt. Now we see the change on the left-hand side. It shows that the contents of the file that are now added to the index, well, it has the same content as what was in the working directory, of course, because we just added it. But that shows you that the version that's ready to be committed now that it's in the staging area is exactly the same as what's in our working directory. And then finally, if we do the commit, then nothing will happen to the working directory or the index, but the repository now reflects the fact that we have one commit. And I've chosen options for the repo history that show a shortened version of the SHA-1 hash on the left, and then some pointer information that both head and the master branch are pointing to this commit, and then the shortened commit message. So that's kind of the first cycle of modify, add, commit. And what I would propose is that the flow from working directory to index down to repository is helped to made a little more visual for learners by actually showing these 3 separate regions. Now let's do another modify, add, commit cycle. Let me clear the screen on the right, and then in mars.txt, I'm going to add a new line. Very unimaginative second line that I've added there. And you see that on the left, it's been updated in the working directory. Now, by having this structure on the left, I believe that explaining git diff can be a little easier for students to understand. So if I take git diff now, of course, the difference that's being compared with this command is from the index to the working directory. And so we see that on that comparison, we have to add the new line to go from the index to the working directory. But if we add that change and we ask for the diff, of course, in the lesson, we show students that there is no change, but we can run that command. Oh, and there's no change, of course, because now the index and the working directory have the same contents. But if we run that command with the flag either staged or cached, then the comparison then becomes between index and repository. And that's shown right here. And now graphically or visually, we can point out to students that this comparison now is between the index and the repository. Let's go ahead and commit that new change. Let's clear the screen. And now let's moving on in the lesson. Let's add another change to Mars. So now we've added a third line, and maybe we don't want that. We can demonstrate to students some of these undo techniques. Of course, we described the checkout command used for this purpose with the 2 dashes and the file name. But we can also show the functioning of reset here. So first, of course, if we do a git checkout head -- Mars, then it's going to compare the version here from the previous commit that only has a second line, and it's going to write it to the working directory here. And that makes that added information go away. So that works as expected. Now, if we do the add a third line again, a new change, and let's say we now we can show the workings of the reset command. But first, actually, let me add it to the index. So now I have the working directory and the index matching. Now, the reset command can be confusing, I think. Generally, it certainly is to me. But the options of soft and hard and mixed and what exactly those do, this is a nice way to visually kind of double check that. So let's just try first the git reset, which defaults to mixed as its option if you don't specify. And we see what happened was it took the, it unstaged those changes, but left the working directory as it is. And then finally, if we pass the hard flag to the reset command, it will also remove changes from the working directory. And so it's a little bit easier to see that in this visual display. So that kind of covers the novice material from the current lesson. And now I'd like to kind of demonstrate why I think this might also be useful covering some more advanced material. So first, in terms of branching, let's say we create a branch. So I'll keep the repo as it is now. We're on the second commit, and the master branch is and head are pointing to this commit. Let's check out a new branch, which we do with git checkout -b. I'll call this one dev for short. Then we can see here easily that the dev pointer now is also in the list. So we have 3 pointers that point to this one commit, head, master, and dev. And we could generate, while we're on the dev branch now, we could make some changes to Mars. And I'm going to go ahead and do that. But I'm going to use another script that's going to make this a little faster. So I'm going to do 2 changes to the file mars.txt. And remember, I just checked out the dev branch, so my changes are going to be on the dev branch. So I expect the master to stay with this commit, but head and dev are going to move up 2 commits as I run this command. And that's what we see here. Now here are the new contents. This generate random change script is a bash script, and it just adds some contents and then makes and then commits them to kind of speed this up. So now we've created a branch, and let's say we've finished our work on Mars. And so we could demonstrate merging. So let's git checkout master. Now we see that head popped down here and points to the second commit. and then we can say git merge dev. And that should move these 2 pointers up, because this is kind of a trivial fast forward merge, but those details are probably not worth going into, and anything but a fast forward may be a little much for this simple tool. And so we see that those pointers moved up. Now the master branch has all the changes that the dev branch had. And finally, we can also, with this kind of view right here, now that we see that master and head are pointed to the same commit, this extra branch right here doesn't really do anything for us. So there's no harm in deleting it, which we do with git branch -d and then the name of the branch. And now you see updated over here. Now we only have these 2 pointers. So that's kind of a nice extension to the basic Git workflow of modify, add, commit, where you could in fact now demonstrate branch, many modified, add, commit cycles, and then merge. And for tidiness, possibly delete that branch. And as another example, let me kind of think about going in it reverse. What if I've done this development and I have made all these changes to master, but my last few are really experimental, and I realize I should have branched because I wasn't quite ready. I'm still figuring this out for my whatever problem I'm solving. So is there any way where I can have master back where everything is safe, and now have a new branch on the more experimental commits that I've made? Well, we can demonstrate that by creating a new branch here at this same pointer. So I'm going to check out a branch. Let's call it feature this time. So I have an experimental feature and I'm not done developing it, and I don't want all these changes on master after all. So first I'll do what might not seem to make sense at first, and that is put another pointer here at this commit. But now let me go back to the master branch. And now I'm going to git reset -- hard, and I'm going to go back before those experimental changes were made. So right now we're in the situation where all I did was create another pointer. That didn't help anything. But now I've switched to master, and I'm going to reset and bring master back down before any of the experimental changes were made, which is what I'm looking for. So now you see on the repo here that indeed the head and master are back before the changes were made, and we have the feature branch that we wanted, and it has the changes, and it's part of a mini project now to develop the feature. And when it's done, we can more safely merge it into master when the time is right. Now, as a final example, I'm going to show git rebase. And to do that, actually, I'd like to start with a new repository. So give me just a moment to clean this up and start fresh. So I'll remove that file, remove the .git directory. So now it's clean, and I can git init there. And then I'm going to run my script again, my IPython script on this bare repository. And I'm going to use mars.txt as the file again. So as a way to demonstrate the git rebase, let's once again make our first file here. Let's add it, and let's commit it. Okay, so now we've got our starting repository here. And let's say for the purposes of rebasing that I start a feature branch. So I'm going to create a new branch and call it feature. And that's reflected here in the repo. And now let me do some development on that. So I'm going to do a new file. I'm going to call it new.txt. And the reason I'm doing that is that it's not going to clutter up the Mars here. And this will make this demo slightly better. You'll see in just a moment, hopefully. So let's create a new file. Now I won't see its contents to the right because that's not what my script is looking at. But let's add it and commit it. And of course, that's reflected on the left here. And then what if we do one more change to that, one more commit and change on that. So we've been developing on this feature branch, but imagine that at the same time that back on the master branch, some other developers perhaps were moving forward the development on Mars.txt. So we'll show that by creating a couple of changes to that file. So now if we look at the repo situation on the left, what we have is the master branch that's moved forward ahead of the feature branch. And the point of rebasing is that there are situations where in the course of developing some new feature, you might want to have the other changes made on the master branch incorporated in your feature branch. And the most obvious way to do that is with a regular merge, but that creates extra merge commits that can clutter the history. And so it's possible to rebase, where you basically take your feature commits and commit them on top of the current state of the master, which has moved along since you started. So the way we would do that is we'd want to be on the feature branch. So we're going to say git checkout feature. I always have to think about which way we do this. We want to be on the feature, and once we're on feature, we're going to git rebase onto master. So what you should see here is that these two commits, the add new text and the modification to new text, are going to be new commits made on top of the last change to Mars. And when I do that, what you'll see is that Mars is going to get updated with the changes that were made previously. And so now we have this cleaner history where, just as I described, this feature branch now has been built on top of where the master had moved to. And indeed, the file, that mars.txt, which this script is monitoring, now in the feature branch shows those changes which were a part of the master branch from before. So that's a demo of the various features. Those are some of the more advanced ones, which I personally feel this split screen really helps with. I have to be honest, I often use this tool when I'm about to do something in Git and I'm a little concerned about what it's going to do. I will, using that generate random change, and then this tool, I can kind of make a structured little repository and try out a command on this throwaway repo and make sure I understand how things are working. So I think this is useful. I think this would be useful for teaching, but I have to say I also kind of use it every now and then in my own workflow just to make sure I'm confident in my Git commands. Okay, so that was the live demo back here on my little slideshow. And so now, how about a quick script walkthrough? It's a very simple script, so this won't take long. So let me stop the script here. And what I'm going to do is, once again, clean this up a little bit so we don't have quite as much, information here. So I clean that out, so there's nothing in this directory, and then we initialize a bare repository. And then on the other side here, I'm in the same directory, and I'm going to run IPython, because I'm going to walk you through just a couple of the commands in this script. So now let's open this script. Okay, now it's a little bit crunched here, but I wanted to leave the font big so that it's easily readable. So on the left-hand side, what you see is the script, and it's really pretty short. It has two dependencies. Of course, three, I suppose. It has IPython because I chose that for the syntax that I like, and then I use time and argparse. And so there's a couple. Here's just the little help file, and then there's two options. There's the lines option shown here, and that's basically defining how many total lines does each of the three sections get on the screen. And then, of course, there's another parameter file. That's the one whose contents is going to be tracked in these various sections. And that syntax here with this little help, the extra pair of dashes here, that's a quirk of an IPython script, because you have to tell the command line, you have to tell IPython, are these command line arguments meant for IPython, or are they command line arguments meant for the IPython script, in this case, the getDemo.ipy. So the dash means anything after it are command line arguments that are meant for the getDemo.ipy. Then after defining a couple of those command line arguments, there's just a couple helper functions here. First, printing lines. So when I pass a list, I'm going to print all the contents of the list, but also I'm going to print blank spaces after it, and I'm going to do as many blank spaces as are left in the total number of lines after my data has been printed. So if I pass the flag of lines equals 6 and my data has 3 lines, then I'm going to print 3 lines of blank space. That way, as the screen refreshes when I make changes, the structure is not moving around. And then the print header is basically just printing whether it's the working directory, the index, or the repo. And I've just kind of wrapped that with some bold escape characters and a dividing line. Then what I do is monitor 3 sections, of course, the working directory, the index, and the repo. And so here's the main loop where I'm going to query whether anything's changed. So in the case of the working directory, I'm going to use the IPython syntax of passing this shell command cat file name. And I'll show you, for instance, here on the right side, what that looks like. So in IPython, first let's write something to this file. Then if I, in fact, let's do a second line. So now if I define a variable in IPython, that's going to be cat of that file, then that is going to be a list that has 2 elements in it for each line. So if so that's what I'm getting here in terms of working, and if it's 0, then it means there's no such file, and I'm gonna, in that case, just a little error handling, I'm just gonna set working equal to 0, so that if I don't have the file in place, it doesn't crash on me. Then for the next one, I'm going to do the command git ls-files-s. And this is what is often called like a plumbing command. The usual git commands that we teach are what's called porcelain commands, kind of the nice, easier to use. And then there's some that help kind of get into the details of the repository database. And this is one of them. And it lets you see what files are in the index. So to demonstrate that, let me first add from IPython, I'm adding that to the index. Now let's run this command, git ls-files, and then the -s is asking list the files that are in the index. And let's take a look at that. So what it's returned is a list with 1 element, and it's got the information on that 1 file. So it's got permissions, it's got the SHA-1 for the current version of that file, and then it's got the name. And so this little bit of processing here that you see on the left-hand side is basically just picking off the first 7 characters of the SHA-1 hash for that file that's in the index. And the way I've designed this, I'm assuming that there's just that one file. So really this can't handle more complicated repos, but I think that's fine. And then the next command here, another plumbing command, if you will, is git cat file -p for pretty print. So I'll demonstrate that on the right. Let's assign that to another variable called temp, git cat file -p for pretty print. And then what this $temp is it's the first 7 characters of that hash. So I'll just type in the first few ones here by hand, B08 BC. And then let's look at what that is. And that again is just a list that has the lines from that file. So now we've got the information from the working directory and from the index. Then the last one here is probably the simplest of all. It's just a git log command. And I'm not going to do any parsing on it. And what I like is to have one line to give the short, decorate, which gives the information about the different branches, branches and pointers, and then all would be covering multiple branches. And then graph is sort of optional, but especially if you're rebasing or merging, I think it's helpful. If you were just doing novice material, I probably would leave the graph off. In fact, it might not even come up, so maybe it doesn't matter. And then there's just one error checking here on the left. If there is no repo in place, no Git repository, then the error message contains the word fatal in it. And if that's the case, then I set the repo to the null string. And then here's the last part of right here. Let me zoom in on that. So what I'm checking here is if any of the values have changed, if the working directory information changed, if the index information changed, or if the repo information changed, then do the following, and that is clear the screen, print the header, then print the lines associated with the working directory, and then so on, the index and the repository, and then of course reassign the variables. And then wait 1 second and continue. So that's a little walkthrough on that pretty basic script there. And so that kind of covers it. As I said, what I like about this is that it gives a visual representation of these kind of 3 important concepts, which I believe would help with student understanding. And I also like it that it's a good little test bed to try some Git commands that if you're not a heavy Git user, using it all the time, and it's nice to have a way to try some things out. And so just in closing, thank you. And I have a link here to my GitHub repository that has this IPython script, and it also has the shell that automates the tmux and screen splitting, which might be useful also. So thank you very much.